Okay, Mel and Marissa, I know you're having trouble with this domain and range stuff, so I thought I'll try this. I hope this works, and I'm just going to kind of wing it and talk about functions. So I hope after I'm done, the functions, domain, range, all that stuff should make some sense. Okay, here I go. Uh, we talk a lot about in Algebra 1 how if you had some kind of equation like this, okay, that this equation was replaced with function notation. So they, back in Algebra 1, took y, crossed it out, and put this instead. F of, and the way you read this is f of x. That's how you read it, f of x. And then they just said equals 5x plus 2. And this is function notation, and what it means is this. If you take the function f and you evaluate it when x is 3, then you will plug 3 into the x value. 5 times 3 plus 2, 15 plus 2, 17 is the answer. So really what's happening is you're putting in an x and you're getting out a y, because remember f is really just the letter y. They replaced it. And you work all these problems out the same, and these problems get harder. Sometimes the function is 5x squared minus x minus 10. So that's a much more difficult problem. All right, but for the most part, that's function notation. How do you evaluate? You put a number in goes 3, out comes 17. So that's how you do that. Now, definition of a function. If you have a function, then the definition says each x value gets exactly one y value. Okay? So, again, this is what you have to keep in mind. All the x values, any x value gets exactly one y value. So if I go like this, 3, 7, 4, 10, 5, 6, then you're going to be asked, is this a function? Well, then you look and you say, did 3 get one answer? Exactly one y value. And it did. Did 4 get one? Yes. Did 5 get one answer? Yes. Every time an x value gets one y, it's going to be a function. So this is yes, it's a function. But if I give you another point, I say 5 comma 1, then 5 got one answer here, but 5 got a different answer here. So now 5, the x value is getting not 1, but 2 y values. So now it's no longer yes, it's a no. Okay? So when looking at points, that's really all it is. Just look at all your x's. If you happen to have a couple x's that are the same and they get different answers, then it's not a function. But if all the x's are different, it's going to be a function. So if I said 6 gets 1, and 7 gets 1, and 8 gets 1. And the question is it a function? And you have to kind of look and say, this x got one answer, this x got 1, and this x got 1, so they all got 1, so this is yes. Okay? But the second I do this, 6 gets 0, then you have to go, no, 6 got 1 and 6 got 0. So that's, the x value gets 2 answers, 2 y's. So now it's no. Okay, now, if you go to a graph, which is what I think you're having trouble with, graphs, there's an easy way to tell if it's a function. Yes or no, is it a function? Okay, something just happened here. Hang on. Okay, has an experience in there. All right, that's not good. Ignore. Can I ignore that? and open up Smart Book, or Notebook, I'm sorry. I hope you're still seeing this. Yes, I want to recover. Okay. And, oh, there it is. It's back. Okay. Now, let's talk about the graph again. If you have a graph, okay, if you have a graph, okay, and you want to know, is it a function, yes or no? Which one? Well, any graph, I don't care what graph you're looking at. You look at this graph, is it a function? Well, what you end up doing is you do what we call the vertical line test. The vertical line test says if you draw a number through this x value 3, if you draw a vertical line and keep going up, 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 3 actually gets one answer because you hit the graph once. -2, draw a vertical line, hits the graph once. Every time you hit it once, there's one answer. It's right there, or it's right here. So if you hit the graph here, this x value 5 got one answer. So vertical line test says if you hit your graph once, yes, it's a function. Now if you hit your graph twice, it's not a function. For example, if you look at something like this, a triangle, okay, there's a triangle, and if I said that's your function and you plugged in 3, if you run your vertical line through 3 gets one answer here, keep going, 2 answers here, and there again, 3 is the x value. 3 can only get one y value. It got one here, one there. So no, it's not a function. Okay? So not this one is no. This one is yes. Okay? Let's see here. That's what we call the vertical line test. Now, if I go into how do you get domain and range, this is probably what you're worried about. Try this one. If I ask you the domain on just a simple line like this, just like that. Now, the domain, which is also known as the independent variable, okay, which is the variable we call x. So these are the independent variables are the x's, and the x's are the domain. So if you want to know what the domain is, you have to look at the x-axis right here, and just kind of look at it and kind of run your pencil from any number on the x-axis. Run it up, it hits the graph. At 8, it hits the graph. At 3, it hits the graph. So all these numbers are getting answers. Even the negatives get answers. -5 gets an answer. -10 gets an answer. So really, and because of the arrow here, it keeps going. So yes, -10 gets an answer. And so does 100. 100 eventually gets an answer. So in this case, we say the domain is all real numbers. Okay? Now the range are the y values. Okay, so here's y. And the range is known as the dependent variable. Okay? Y depends on whatever you plug in for x. So what's the range? Well, in this case, here's what I do. I just grab a number on the x-axis. I try 8 again. 8 goes up, gets an answer. Where's the answer? Right there. This is the y value. I don't know what it is. Let's say 10. 3 goes in, comes across, it gets 5. Now, when you look at it, every time you hit the graph, come over, you get more y values. And you keep getting them forever up. You also get them forever down. Go hit the graph, run it over, look, it's right there. Keep going down, it's right there. So really, when you look at it, all the y's come out of this thing. So again, all real numbers. That happens a lot. The real numbers happen a lot when you start getting arrows on the end of your function. Arrows basically mean the function goes on forever, and forever usually means the real numbers. Except, I'll show you one that doesn't quite mean that. So if I give you this look, okay, right here, and I put arrows on this, and I put arrows on this, okay? Now, if I did the domain on this one, if I pick, let's go 6, and I go up, I hit it. Okay, so 6 gets an answer. if I pick 10, 10 eventually gets an answer. If I pick 100, it would eventually get it because this thing keeps going outward. So would negative 100. So would 0. 0 would get this answer. Oops, sorry. 0 would get this answer right here. So everything gets an answer in this one for the domain. So it's all reals. But when you talk about the range, now the range is different because the range would be this way. 6 gets an answer, it's right here. 10 gets an answer, it's right here. 0 gets an answer, it's right there. Now what happens is this little y value right there, that's the lowest y value. Let's pretend it's negative 2. So then the range, if you look at the drawing I just drew, really the range, negative 2 comes out, but so does negative 1, so does 0, so does 1, so does 2. So I mean, if this is 3, 2, 1, these are all coming out. So when you look at it, to me, it's all the y's this way. So we'd say all y's will be greater than negative 2. Okay? And there is a case where you have arrows, but it isn't all reals. In this case, it's all reals for domain and all y values greater than negative 2. Then you will see things like this. You will see like line segments. Line segments like this from there to there. Okay? And sometimes the endpoints are open and closed. If it's open, like this one right here, this means this point doesn't exist. Okay? So if it doesn't exist, whatever this number is right there, let's just pretend it's 7. 7 goes down, hits it. 7 actually doesn't get an answer. But what does is 6 gets an answer, 6.5 gets an answer, 6 and 3, 4, 6.9. So anything less than 7 gets an answer. So there we go again. It's domain. All x's have to be less than 7. Just less than, no equal, because it can't equal 7 because of the open dot. Okay? Keep going. Well, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4. Let's call this negative 5. And because this is closed, this point does exist. So what would that mean? It would mean negative 5 is in the domain. So what we do is we put the low number on the left, the high number on the right, and then we put the correct signs in. Well, this one is less than 7, less than, not equal because it was open. But this one is going to be greater than, x is greater than negative 5, or equal to negative 5. Okay, now, that's it. That's the domain. You're basically telling me from negative 5 all the way up to 7, the x's get answers. Not 7, though. That's why we didn't put the equal. So what's the range? Well, the range is going to be the y values. Well, the y values are from, this is the lowest y value, right? This point. Go this way. This comes out. 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 Okay, here we go. Last one's right there. Let's say that's 6. Let's say this one's negative 2. So from negative 2 all the way up to 6 comes out. The number 6 actually came out because it's closed. So 6 is the largest. Negative 2 is the smallest. Because it's all less than 6, we'll go less than. And because this one's closed, we're going to put the equal sign. This one down here, negative 2. Negative 2 did not really come out because it's open. So we just go greater than negative 2. And that's all. We don't put the equal sign or else we're going to get it wrong. Okay. I don't think, I'm sorry, there is one more thing, and that is the story problem. So if I did this really quick and I said something like this, let's just say good old Bill makes $10 per hour at his job. okay? And let's say he works no more than 12 hours per week. Okay? So you'll get story problems like this. And then they're going to ask you this. What's the independent variable? What's the dependent variable? Okay? And the independent variable is always going to be the variable that you control. Okay, so really there's a couple things that are happening here. It talks about what he gets paid per hour, but that's what we're comparing here is more than that. It's more or less we're comparing the hours he's working, and I know it doesn't say this, but really what we're worried about in this kind of problem is what's his pay? What's his payment? So to me, the things you're worried about in this problem, you're comparing two things: his payment versus his hours. Okay, so what the variable that you control is going to be right here, the number of hours. And the only reason you control the hours is because you can actually say, I want more hours or I don't want more hours. You really can't control your paycheck because you can't control what you get paid per hour. So this is independent, number of hours. So the dependent variable will be amount of, let's say, paycheck. Okay, so there is your independent variable, there's your dependent variable, and the next thing you'll do is you'll run the independent variable over and call it your domain, because that's what the domain is. It's the independent variable. So in this one, it says number of hours. Well, number of hours, it says up here, I'm sorry. He what? Works no more than 12 hours per week. I'm sorry. It's 8 o'clock at night and I'm tired. So anyways, number of hours, that's the independent variable. That would be, he works no more than 12, so it would be hours. Hours would be less than or equal to 12, but greater than or equal to 0. So there's the domain. And the dependent variable, that's your range. So the range is going to be, well, you got to look at the domain, and the domain says he works 0 to 12. And since he gets paid $10 an hour, well, 0 hours is going to make him $0, where 12 hours, if he works his maximum, will make him 120. So his paycheck, P, will be less than or equal to that, but greater than or equal to 0. So this is his paycheck, which we call the outputs. Here come the inputs. He puts in this many hours, and he gets out his paycheck. And that's how story problems, all of them, pretty much work. I hope that helped you, and I hope this worked, or just comes through for you, okay? All right, Marissa, good luck on your homework, and Mel, good luck trying to figure it out and help her, okay? Take care, you two.